The concept of 0 times infinity is one of the most intriguing and perplexing topics in mathematics, blending the abstract ideas of nothingness and boundlessness. At first glance, the expression seems paradoxical. 0 represents the absence of quantity, while infinity represents something without a limit. We'll explore the mathematical interpretations of 0 times infinity primarily through the lens of calculus and examines the philosophical implications of this enigmatic expression. In calculus, the expression 0 times infinity is classified as an indeterminate form. When evaluating limits, if one factor approaches 0 while another approaches infinity, we cannot simply substitute these values and multiply. Unlike determinate forms that always yield the same result, indeterminate forms can lead to any value depending on the specific functions involved. Let's examine 3 examples that illustrate this indeterminacy as x approaches 0. First case, as x approaches 0, the value of x tends towards 0 while 1 over x grows without bound toward infinity. Their product equals 1 for any non-zero value of x, so the limit equals 1. Here, the rates of approaching 0 and infinity precisely balance each other. The second case, as x approaches 0, the term 1 over x squared grows toward infinity much faster than in the previous example. So the product can be written as 1 over x, which approaches infinity as x approaches 0. In this case, the infinity factor dominates. Third case, as x approaches 0, the term 1 over x squared grows toward infinity but more slowly than 1 over x. So the product approaches 0 as x approaches 0. Here, the 0 factor dominates. These examples demonstrate the value of 0 times infinite depends critically on the specific rate at which terms approach their respective limits. It is important to distinguish between multiplying 0 by infinity and adding 0 an infinite number of times. While 0 times infinity is indeterminate, the sum always equals 0. No matter how many zeros we add together, the sum remains 0. This highlights a fundamental difference between multiplication and addition when dealing with limits and infinite processes. This distinction is crucial in calculus, where infinite series often arise. The concept of 0 times infinity also has deep philosophical implications. 0 and infinity are not just mathematical abstractions. They are deeply rooted in human thought and culture. 0 represents the void, the absence of existence, a concept that many ancient civilizations struggle to formalize. Some philosophical traditions viewed nothingness with suspicion or fear, while others embraced it as a necessary complement to existence. In Buddhist philosophy, the concept of emptiness shares conceptual territory with mathematical 0, suggesting that emptiness is not mere negation but a profound state of potential. Infinity, conversely, represents the eternal, the unbounded, and the incomprehensible. Western philosophical traditions, from Aristotle to Kant, have debated actual versus potential infinity, while Eastern philosophical systems often embrace the infinite as an expression of ultimate reality. The expression 0 times infinity transcends simple arithmetic, revealing the subtle interplay between concepts that seem diametrically opposed. Through calculus, we understand that this indeterminate form represents a mathematical boundary where outcomes depend on the specific paths taken toward zero and infinity. This mathematical ambiguity reflects philosophical tensions between nothingness and boundlessness, concepts that have fascinated thinkers throughout history. The paradox of zero times infinity invites us to reconsider our intuitions about the nature of reality, existence, and the infinite. Thanks for watching. If you found this video helpful, give it a thumbs up and don't forget to subscribe to the channel.